Okay, look, it's day 3 of Paris Air Show. We're still here, still motoring through. Still a few days to go for you. It's our last day here, so still enjoying the sun. I'm joined by David Ziegler. We're on the Dassault Systemes chalet. Again, really nice to be on chalets because it's a nice experience. David is the Senior Vice President for Aerospace
and Defence.
And Defence. Okay. We will talk about a bit about defence because it can be relevant for the commercial aerospace sector, but we'll focus on aerospace in particular and what you guys specialise in. So, David, over to you. Tell us what it is you specialise in, and what are you talking about to the clients here this week?
Right. So, as you said, third day. Well, we're getting a little bit of sun here, but we're in full swing, and Dassault Systemes has been at the forefront of innovation in aerospace and defense for the last 40 years. What we do simply is virtual twins for the real world.
Okay, yeah. So this is virtual 3D. It's as close to the real world as you get it. I know that technology is developing all the time, so these are things getting even more sophisticated.
Right. So
explain how sophisticated this thing is now, because I guess if you don't work in business and you're on the outside, you see metaverse, you hear about it. It's like a computer game, which are very sophisticated and very realistic these days. But what are we talking about when we're thinking about business-to-business commercial application of this technology?
So let's rewind a little bit and discuss about the first virtual twins.
Yeah.
Really, we as Dassault Systemes history, we were born out of Dassault Aviation.
Yeah.
So we were born in aerospace and defense. And really 40 years ago, we started to provide our customers with the ability to actually model and design one piece of aircraft in 3D. And that was 40 years ago. Then we stepped up our game to provide what we call virtual twins. The 777 of Boeing was actually the first aircraft that was fully digitally designed into this virtual world.
Okay.
So all the mechanical interfaces, all the digital mock-up was the first for the industry for commercial aviation.
Yeah.
That was back in the 90s. Then we moved into what we call PLM, or life cycle management. Essentially, the way to make your virtual twin evolves through the configuration and through time. In 2012, we launched what we call the 3D Experience Platform, which is actually adding a lot of stuff to that virtual twin. It's not only the physical representation of your product, but it's the way it behaves.
Yeah.
So it shows how you can simulate the flight conditions, the efforts on the wings, how the resistance on the structure, the thermodynamics, really every type of simulation.
You can manipulate and test it in this world, and it's just as good as testing it in the real world.
So we're getting there.
Yeah.
What you refer to is certification by analysis,
Yeah.
which is essentially how you can get rid of all the physical testing that are obviously very expensive and debug everything up front into the virtual world.
Yeah.
We will still need physical tests, that's for sure, but we're moving there with more and more precise simulations. And recently, what we're really, I would say, enthusiastic about is what we call 3D universes.
Okay.
It's actually the connections of these virtual twins of different products, the virtual twin of the aircraft, the virtual twin of the factory, the virtual twin of the supply chain, to solve much bigger problems, to solve systems of systems.
And the airport, I know the airports are all developing digital twins. This is all about, a lot of this is being used to make the industry more efficient and effective, which is, I think you get that sense that this is what it's all about at the moment. There's a lot of strain on the industry, demand is there, but really supply chain is struggling.
Right.
So this sort of thing can help with that.
Definitely. The first point about a virtual twin, it's about engineering at the start, right? Mm-hmm. Engineering is at the core of the virtual twin, and really what it helps you perform is to reduce your development life cycle. Why? Because everybody is working on the single source of truth, and it enables collaboration at an extending range between engineering to manufacturing, together as well with support and services, so they all collaborate on the same platform and achieve the same design goals.
Yeah.
That was true really since the first stages of the virtual twins. Now, where we are getting, and what's really interesting is the second virtual twin, the virtual twin of the supply chain.
Yeah.
How do you map the risk into your supply chain? How do you make sure you're not single source on what really matters for you? how are you going to distribute the work package as an OEM to other equivalents? This is the virtual twin of the supply chain.
Yeah. There's been a lot of talk about the supply chain this week. As inevitably, I was on RTX media update yesterday, and it was said there that the bottleneck, the problems at the MRO level, are going to be solved by, they're caused by lack of material. So fine. This is very logistics. Things have to be in the right place at the right time. Adopting this technology can at least help with that. It'll tweak the dial by a number of percent, and that can be crucial.
Definitely. Supply chain issues are really relating, first to the state of the supply chain after COVID and probably a lack of investment. But as well, it's the way that OEM can better schedule what is the capacity of the supply chain. What is the relevant second source I could pick up? And right now with the tariff wars, it increases the problem. Why? Because it's not only a problem of cost and performance of the supply chain, it's also about the location of the supply chain and reinsourcing. It's also about, I hear often, yes, but the materials don't arrive in time and all of that. We need to keep in mind that even if you find the right person, the right material, then you need to recertify that full process, and it takes a very long time. So a model-based approach toward your supply chain really gives you the ability to achieve certification better, which is another benefit of the virtual twins.
Yeah, there's a time to market gets squeezed, and that's just things happen more quickly, which is what we need at the minute, obviously.
Exactly.
We often talk a lot about digital twinning in our business through MRO Management, one of our magazines, but we run the Predictive Aircraft Maintenance Conference, and that is all about prediction, modeling, trying to know what's going to happen in the future, so you're ready for it, and So this is very much relevant to that conversation. Where does digital twinning sit in predictive, and does predictive happen without a digital twinning, a very sophisticated digital twinning system?
So first, we like to call it at Dassault Systemes virtual twin, because it's not about digitalizing the past and making a capture of whatever your plans were in 2D. It's really from the get-go to get not only the digital mock-up, but the full systems overview. And then what we're seeing right now, having a virtual twin is really making sure that you close the gap between that virtual twin and the real-world product.
Yeah.
Sorry about that.
Excuse you.
So really about closing that gap, we are going to see virtual twins age.
Okay. Age. As in get older. Okay.
You can do the virtual twin of your aircraft, right?
Yeah.
And you know how it's going to behave at nominal conditions, which is never the case in the real world.
Sure, yeah.
So how do you model that change? How do you model that aging of the aircraft?
Yeah.
Well, the answer lies with the access of that virtual twin to the real flight operations data that is coming from the aircraft.
Okay.
And once you're getting that V plus R, virtual plus real together, you've got a new kind of virtual twin.
You're kind of moving away. Yeah, you're moving away from just using historic data, which is often based, I think, isn't it, on benign conditions. But if you're operating in an aircraft in the Middle East or a fleet in the Middle East, you're never in benign conditions. So you're operating in harsher conditions. So you need to be ready for what's going to happen to your engine blades.
Exactly. So, and to give you a precise indication, we're working with Dassault Aviation, our sister company, where essentially for the fleet of the French Air Force, they are taking all the flight operations and maintenance data on a daily basis. They are putting all that data back into our servers so that we can use that data, put it into context of the virtual twin in order to decrease the cost of support and increase the level of availability of that aircraft.
Right.
Since we embarked on that project 2 years ago, and of course there are many reasons, but the availability of the French fleet of the Rafale has increased by 10%.
Okay.
And as a French taxpayer, I can tell you,
You're happy.
pays my bills.
Has your tax bill gone down?
Unfortunately not, but probably not because of the Rafale.
So defense is interesting. We said we don't cover defense, but actually what you said there is a learning from a defence scenario, which can be then manipulated or transcribed into the commercial world, because obviously fleet usage is absolutely critical. So is that happening through companies like you, that what you learn in the defence area, that is coming into commercial all the time?
Exactly. And when you are seeing what we're doing with Dassault Aviation, actually, we are using algorithm to predict maintenance failures.
Yeah.
So this is how actually we are able to better increase the fleet availability.
Yeah.
And that technology is available not only for our defense customers, but for our commercial customers as well.
Yeah. If you can boil it down to anything for aviation in these days, it's just let's minimize the AOGs. It's just let's get these things flying safely and as often as possible, because that's when you make money.
Exactly.
Let's talk about people.
So there is a real emphasis on this, on what we call design for service.
Okay.
So what is design for service? Typically, when you design an aircraft, the chief engineer comes in and he's got brilliant ideas and he makes something that is not manufacturable. So people take a lot of time in manufacturing to make that happen. And that was the case like 20, 25 years ago. Now the teams are really getting to work together to do both the design for engineering and the design for manufacturing at the same time, using our platforms that allows collaboration.
Yeah.
Now we're going a step further to allow the support and services guy to really look at the upfront design of the aircraft and make sure it's maintainable in the right way.
Yeah.
Simplifying sometimes
so it's baked
the
in from the
design.
beginning, essentially.
Yeah, simplifying the design. Just that part has too many screws and it takes too much time to take that part out.
Yeah.
Simplify that design piece. It's a way to accelerate.
You do see this in other areas, and this is a space event as well.
Yeah.
And I think you do see it in the latest craft going into space. Visually, they just look simpler and simpler and simpler. And,
So
and it's a visual.
the best example is Virgin Galactic Delta class spaceship.
Yeah.
Virgin Galactic, who developed its aircraft on the 3D experiences, is really getting the full traction of integrating design, manufacturing, and service together.
Yeah.
Why? It has a real bottom line solving
Benefit.
issues or benefit for them.
Yeah.
The first aircraft, Unity, was a great trial aircraft. Let's put it this way. They went, I think, in the range of 30 aircraft flights in space. But then they looked at the business case and said, "Come on, it's really about doing that massive transportation to space. Not like an Airbus would do. They are not there yet, but at least being able to fly once or twice a day with an aircraft. And in order to do that, if it takes 1 month to do the maintenance after each flight. Remember, this aircraft is flying back from space, so you need to do a lot of inspections of the thermal
heavy
protection.
usage. This is
So it's not a simple rollout of the aircraft, but it needs a lot of inspection time. By redoing the design and then taking a design for service approach, they completely reduce the maintenance task, making sure it's still safe to operate, but being able to get better usage out of it, and therefore better business case.
Yeah. So that's another example of cross-learning between now space and that can obviously, what they're learning there goes into commercial. I think there's also a lot of that going on with the urban mobility guys and the eVTOL.
Yeah.
So we saw Archer earlier in the week, which is an amazing-looking Batmobile they've built. Just stunning. But they're doing stuff there engineering-wise, based on what they want to do for that aircraft. That it's the first time. It's unique, but they're doing it I think they're doing it in a similar vein, aren't they? They're taking this approach,
Exactly.
and that learning is being pushed off into the rest of the aerospace.
You see actually a lot of technology coming in. For example, Joby Aircraft as they're number one in advanced air mobility. They are using our platform, of course, but they're using new tilt rotor technology, which is brand new. On top of that, developing an electrical vertical takeoff and landing aircraft, same as Archer. So a lot of technology goes into this. You might have seen Blue Spirit Aero. It's a first world event. It's a clean sheet design aircraft for hydrogen-powered aircraft.
Oh yeah, right. What's the name of that one again? That was
Blue Spirit Aerospace.
Okay.
You can visit them. Just around the corner. But it's a magnificent team. Its best showcase are a very small team of engineers. It's a group of 15 people right now. Are able to develop a small aircraft that actually has done its rollout a couple of weeks back, and that intends to fly before the year is over.
Okay.
So that's really an amazing speed in order to develop an aircraft on new technology.
And that's the sort of hydrogen is one of the options for future fuel propulsion, and it's been We know it's being heavily investigated by the likes of EasyJet in collaboration with Rolls-Royce and all that. That's happening. It could happen. It does require because it's a different kind of fuel. It does require massive changes in infrastructure. But again, this is where the 3D element comes in, because you can test the impact on the infrastructure before you put a spade in the ground. Yeah,
exactly. So our customers, and many of them, whether you talk about hydrogen or even if you talk about the charging stations that you need for electrical aircraft, our customers are using virtual twins technology to model the supply chain and find out where in your space of operations you want to have these actually power stations to power your aircraft.
Yeah, okay. Let's go on to the people side of it as well, because these new ways of doing things, these new interfaces, they're highly technical, very different to what an engineer or a designer would have used 30, 40 years ago. I mean, it's been happening since then, but it's very different today. How does that change the way, I guess, you bring in the right talent, recruit and find and develop the talent that you've got in your business, but in aerospace in general?
So I think in aerospace and defense, the challenge is really that wave of retirement that we're seeing. And
the older, I mean, they're very experienced, these guys. They know what they're doing.
Exactly. With a lot of experience, but with a lot of tribal knowledge. You know, it's a guy that comes, that look at the aircraft and says, the problem is here.
Yeah, but it's also in here as well, isn't it?
But it's in his head. So what we're doing with our platform is we like to call it a platform of knowledge and know-how, because we embed our customers' knowledge within the platform. And that helps them actually to standardize operations and make sure everybody knows how to operate. Going further, we've got actually digital technologies. The new workforce of the future is digitally native.
Yeah.
And we are changing the way they operate, from being a shop floor guy to somebody that is actually supervising the operations, that is able to reprogram these robots. And they are evolving from shop floor workers to technicians. The technicians are becoming engineers.
It's a high-tech job now. We used to be a greasy job on the shop floor. Now you're sitting behind a computer programming, maybe.
Exactly. And our technology enables to project work instructions directly on the structure of the aircraft you are building, or with other type of technologies, whether we're talking about Apple Vision Pro or other type of device, where you can really learn how to do the job, but also be instructed by the machine to do your job. And where it becomes really interesting is that we're moving away from doing things right the first time to doing things right all the time.
Okay, and there's an ongoing issue with workforce, which we spoke about before we started. That's not going to be suddenly solved, but actually it's this kind of thing that if the general public, the young people coming through school and college, they see that this is the kind of work you do in aerospace these days, that is what's going to excite them, isn't it? That's going to get them into the business. Whereas if they still think it's a bit old school, it's a little bit manual, then it may be not for them. And that's a message that I think has to get across.
Exactly. You know, I think we're very lucky in aerospace, because it has been the dream of mankind flying since the dawn of ages.
Yeah.
And when you look at these beautiful machines, there is a lot of engineering prowess that goes into that. So it's really a dream for engineers. But beyond that, we're moving away from that greasy shop floor image that sometimes you have with aerospace manufacturing. If you go to see Airbus plants these days in the A350, you are going to see not that many people on the shop floor. Everything is automatized. You've got riveting machines, assembly machines. So a lot of it is actually transformed by robotics. And it's a new kind of job.
I was lucky enough. It's another sector, but I think where there's a lot of parallels. Lucky enough to go and see the Aston Martin Formula One HQ in Silverstone last year. And it's like a hospital. The cars are like patients. They're treated with the deference of the patient, almost on a table with sort of probes and computers. You didn't see a spanner in sight. 3D printing. There was, amazing. But it was very similar, I think, to how aviation is headed.
So aviation is following the trend on automotive. Automotive, it's not about producing. Even Airbus is producing around 1,000 aircraft a year, which is already a challenge in terms of ramp up. We discussed that. But really, automotive players are producing. Each of them is producing in the range of 10 million vehicles a year. So you clearly need to automate everything. And actually, aerospace is learning a lot from the automotive industry to make sure they're able to ramp up and manufacture at scale.
We're nearly out of time, but you mentioned the word ramp up, and actually I've heard that word or phrase used quite a few times in the last 3 days. What do you take away from this year's air show? That it feels like the sleeves are rolled up, time to get on with it, and that's the ramp up situation, isn't it?
Exactly.
We've got problems, but we're not moaning about them anymore. We're getting on with it. Is that how you
So
feel?
there is a fantastic runway for commercial aviation. It's about multiplying the rate of production by a factor of 2 over the next 3 years. So really the industry is booming. And we're seeing, it's a dual industry as well.
Yeah.
And we're seeing a lot of investments in defense. We've got a lot of commercial players that want that defense business in order to balance their business case. So we're seeing a lot of investment in A&D going forward.
Yeah. David, that's it. We have to wrap it up, but thanks for joining us while we're here at Paris on FRABNcast. We'll see you again at another show in the near future, I'm sure. I hope you have a good rest of week.
Thank you, Lee. We'll have a brilliant week.
Don't get too sunburned, and I can see it's already busy, so you're going to be kept busy the next few days.
All right.
Thank
you, Lee.
Cheers. Thank you. Cheers.